Hey guys, so today I'm going to be telling you about labeling refraction diagrams. So a few terms that you're going to hear a lot during this diagram drawing is incidence, reflection, and refraction. So we'll get to those once we actually begin drawing the diagram. So first, we're going to start out with our boundary line. This boundary line is what separates the two mediums. In this case, we're going to be using air and water. So as we know, the refraction index of air is less than the refraction index of water. So this means that light will travel quicker in air, so this is fast, than it will travel in water, which is relatively slower than the speed of air. So everything needs to start with a source. So this is going to be our light source that's going to be emitting our light. First, we're going to start out with a ray that's going to go down, okay? And then this is going to be called the ray of incidence. So incidence is kind of what's starting out this whole process. So now I'm going to decrease the transparency, and we're going to go for drawing another ray. This ray is going downwards. Let's draw that in red. This ray is going downwards. This ray is going upwards. We're going to give it the name of ray of reflection. So why is this called ray of reflection? Because it's reflecting. It's reflecting off this boundary line. Okay, so now that we have these two rays of reflection and incidence, we're going to go for drawing our third ray, which is going to be over here. I'm going to draw it a little bit thicker and a little bit stronger. Okay. So this ray is going to be called the ray of refraction because it's refracted. This is an E. Oh, ray of refraction. Refraction. Okay, so this is the ray of refraction because it's being refracted. It is also pointing downwards, and the intensity is a little bit less than the original, but it's more than the reflection. Okay, so now that we've got the rays down, we've already seen incidence, reflection, and refraction. We're going to talk a little bit about the angles. So as you can see here, oh, and we can't forget one very important line, which I'm going to use a ruler to draw, which is the normal line. So the normal line is what's going to be separating all these different points and lines and rays. It's very important to draw normal line. Okay, so once we have all these rays down, they all collectively meet at this one point, which you can guess is called the point of incidence. All right, so once we've gotten all that down, let's start talking about the angles. So angles are going to be in blue. This angle is going to be equal to this angle. So these are equal angles. And since we can see that this is kind of a 90-degree and the normal line is always perpendicular to the boundary line. So that means that respectively, these two angles are also equal. All right, so let's say this is theta. This will be theta A, and this will be theta A. If this is called theta B, this will also be called theta B. So they are equal in measure. Okay, now let's talk about how we draw this ray of reflection. So the ray of refraction. So since it's going from a fast medium to a slower medium, the ray of refraction is going to come towards the normal line. What do I mean by that? So if this line were to continue, it would have continued somewhere along here, right? This ray of incidence. If If it continued, it would go from here, it would continue through this, right? So once we realize that the ray is going from a fast medium to a slower medium, it will move towards the normal. That's the ray of refraction. However, if the ray of incidence is going from a slow medium, so let's say this was slow and this was faster, the ray of refraction would go away from the normal and away from the initial ray. So if that's unclear, we can make another video on that. But that's basically the gist of it. That's so we remember, if it's going from fast to slow, we're talking about mediums here, it will go closer to the normal. If it's going from slow to fast, it will go away from the normal. Okay, so that's just a note to keep in mind. And yeah, that's basically how we draw a refraction diagram. I hope this was helpful.